In this video, we're going to look at case 4, where q of x, the denominator, contains repeated, irreducible quadratic factors of the form ax squared plus bx plus c to the power of m, where b squared minus 4ac is less than 0. This is what makes the factor ax squared plus bx plus c irreducible. So the function f of x is equal to p of x divided by q of x will have the partial fraction decomposition that will be in the form of a sum. So we'll get f of x is equal to p of x divided by q of x. That's equal to a1x plus b1 divided by ax squared plus bx plus c plus a2x plus b2 divided by ax squared plus bx plus c all squared plus a3x plus b3 divided by ax squared plus bx plus c all cubed, all the way up to amx plus bm divided by ax squared plus bx plus c to the power of m. So the key concept is to repeat all the way up to the highest power of the repeated quadratic factor. So some examples of repeated quadratic factors that are irreducible are x squared plus x plus 1 squared, 2x plus 5 times x squared plus 4 squared. It is this part that's repeated, irreducible, and quadratic. And also x times x minus 1 times x squared plus 2 cubed. It is this part that's repeated, quadratic, and irreducible, and it's repeated all the way to the power 3. All right, so now let's find the partial fraction decomposition of the following rational functions. The first case, we have 1 over x squared times x squared plus 1 all squared. We will write this as a divided by x plus b divided by x squared plus cx plus d divided by x squared plus 1 plus ex plus f divided by x squared plus 1 all squared. Let's look at another example. Here we have t divided by t plus 1 times t squared plus 4 all cubed. So we do the partial fraction decomposition. We have a divided by t plus 1 plus bt plus c divided by t squared plus 4 plus dt plus e divided by t squared plus 4 all squared plus ft plus g divided by t squared plus 4 all cubed. The key concept is to repeat all the way up to the highest power of repeated irreducible quadratic factor ax squared plus bx plus c to the m. In this case, our m is 3. All right, let's look at an actual example. Here we have evaluate integral 1 over x times x squared plus 4 all squared. So the first thing we do is we check the degree of the numerator and denominator. The degree of the numerator is just 0 because the numerator is a constant. 1 is a constant, its degree is 0. The denominator, if you were to open it all up, you would get the degree of denominator would be 5. And 0 is less than 5. The degree of numerator is less than degree of denominator. That means we apply partial fraction decomposition. So the pattern will be, it will be in the form of a sum. We get a over x plus bx plus c divided by x squared plus 4 plus dx plus e divided by x squared plus 4 all squared. So the next step is to clear out the fractions by multiplying both sides by x times x squared plus 4 squared. On the left-hand side, we're going to get 1. On the right-hand side, we're going to get a times x squared plus 4 all squared plus, multiplied by the second term, we get bx plus c times x squared plus 4. Let's put the x in brackets as well. Plus, and the last term, we're going to get dx plus e multiplied by x. Let's multiply this all out. We get 1 is equal to a times and opening this up, folding it out, x squared plus 4 all squared. The first term gets squared, we get x to the fourth, plus 2 times the product of the terms. The middle term will be 2 times the product of the terms. We get 8x squared plus 16 plus bx plus c. Let's multiply the x through, and we get x cubed plus 4x plus dx squared plus ex. If we rearrange this so that we have all the powers of x to the fourth together, all the powers of x cubed, x squared, x, and a constant term, we will obtain 1 is equal to a plus b times x to the fourth plus cx cubed plus 8a plus 4b plus d times x squared plus 4c plus e times x plus 16a. Alright, so now we can equate equal powers of x. Let's look at the power of x to the fourth. On the left hand side, the power of x to the fourth is just 0. On the right hand side, the power of x to the fourth is a plus b. So we have our first equation. Let's look at the power of x cubed. On the left hand side, the power of x cubed is 0. On the right hand side, the power of x cubed is c. The coefficient of x cubed, I should say, is c. On the left hand side, the coefficient of x squared is 0. On the right hand side, the coefficient of x squared is 8a plus 4b plus d. And power of x. On the left hand side, there's no x term, so the coefficient of x is 0 on the left hand side, and the coefficient of x on the right hand side is 4c plus e. Now let's look at the coefficient of x to the 0. On the left hand side, the only constant term is 1. On the right hand side, the constant term is 16a. Alright, looking at the last equation, it's clear that a is equal to 1 over 16. The second equation gives us c is equal to 0. And the first equation gives us b is equal to minus a. That means b is equal to minus 1 over 16. And the fourth equation gives us e is equal to negative 4c. But we already know that c is equal to 0. That means e is equal to 0. Now let's plug a is equal to 1 over 16 and b is equal to negative 1 over 16 into the third equation, into 0 is equal to 8a plus 4b plus d. We obtain 0 is equal to 8 times a, that's 1 over 16, plus 4 times b, 4 times negative 1 over 16, plus d. Solving for d, we get d is equal to minus 8 over 16, plus 4 over 16. 4 minus 8 is negative 4, we get negative 4 over 16. That simplifies to negative 1/4. So we have now solved for a, b, c, d, and e. Let's write all of those down. We solve for a is equal to 1 over 16. b is equal to negative 1 over 16. c is equal to 0. And d is equal to, we solve for d is negative 1/4. And e is 0. So now we have all the coefficients. The partial fraction decomposition has been completed. So what we have is a equals 1 over 16, b is negative 1 over 16, c is 0, d is negative 1/4, and e is equal to 0. So the partial fraction decomposition has the form a over x plus bx plus c divided by x squared plus 4 plus dx plus e divided by x squared plus 4 all squared. Putting these numbers in, we have 1 over 16 divided by x plus b is negative 1 over 16 times x divided by x squared plus 4. C is just 0, so we don't write anything down for that. Plus d is negative 1/4, so we have negative 1/4 times x, and e is 0. Similarly, we don't write that. Divided by x squared plus 4 all squared. So now the partial fraction has been completed, we can do the integration. So we have integral of 1 over 16 divided by x minus 1 over 16 x divided by x squared plus 4 minus 1/4 times x divided by x squared plus 4 all squared dx. Now let's split up the integrals and pull the constants outside. So we simplify a little bit, makes it easy to integrate term by term. We have 1 over 16 integral 1 over x dx minus 1 over 16 integral x over x squared plus 4 dx minus 1/4 integral x divided by x squared plus 4 all squared dx. Now the first term can be, the first integral I should say, can be easily integrated. So we do that right off the bat. That's 1 over 16. What's the antiderivative of 1 over x? That's log x. So that's ln, absolute value of x. And we'll just rewrite all the other one, the latter two integrals. We're going to need to use the substitution method for those. X over x squared plus 4 dx minus 1/4 integral x divided by x squared plus 4 all squared dx. Alright, so now we're going to use the substitution method. On the second integral, we're going to let u be equal to x squared plus 4. Its derivative will be a constant multiple of the numerator, and that's why it works. So du will be differentiate both sides, we get 2x dx. And divide by 2 both sides, we get du over 2 is equal to x dx. And for the second integral, we do exactly the same. We make the same choice of substitution, let u equals x squared plus 4. Differentiate both sides, du is equal to 2x dx. Divide by 2, we get 1/2 du is equal to x dx. Alright, so what we have carrying over the solved integrals, so let's carry those forward. We get 1 over 16 log of x. This part was done earlier, minus 1 over 16. Well, integral x dx is 1/2 du, so that's 1/2 du divided by u minus 1/4 integral x dx, again is 1/2 du divided by u squared. And we get 1 over 16 log of absolute value of x. Now let's remove the constants and organize this a little bit. We get minus 1 over 32 integral 1 over u du. And pull out the constant 1/2, multiplies by 1/4, we get 1/8. And we will rewrite 1 over u squared as u to the minus 2 because it will make it easier to apply the reverse of the power rule. So u to the minus 2 du. 1 over 16 log x minus 1 over 32. Integral 1 over u is log of absolute value of u minus 1 over 8. Now applying the reverse of the power rule, we get u to the minus 2 plus 1. That's u to the minus 2 plus 1, that's negative 1. Divide by negative 1 plus c. Let's simplify this. We get 1 over 16 log of absolute value of x minus 1 over 32 log of, well, we did a substitution, u is equal to x squared plus 4. So let's put that back in. Log of x squared plus 4 plus 1 over 8 times 1 over u, and u is x squared plus 4. And don't forget to put the constant c. This is the answer. All right, thanks.